This is Noah Smutz. He's a book conservator in St. Louis. He restores rare books, family Bibles, and even centuries-old manuscripts. And one of the most important tools in his shop is a book press. The problem is, the one that he just bought at auction showed up in pieces. So naturally, we're gonna rebuild it. The Wood Whisperer is sponsored by Woodcraft. Just get started. This book press was made in 1905 by Hickok Manufacturing, a company that's still in business today. Noah brought the damaged pieces to the shop so that we could decide on a course of action. The press is a combination of wood and cast iron components. The top screw and platen are held in place by a large cast iron crossmember, and in use, this thing can generate thousands of pounds of force. Needless to say, the wood components need to be structurally sound, and after the shipping damage, they just aren't. Apparently, when they put this on the pallet, they used 4 screws through the feet and into a plywood base, and being super top-heavy, the press took a little tumble. The pegged mortise and tenon joints kind of exploded, and every crucial connection point ended up with a crack or two. The big beautiful cast iron wheel was broken in half. Noah plans to have a new one made, and one of the cast iron runners broke right down the middle. So we decided that the best course of action would be to rebuild the wooden components, coupling them with as much of the original cast iron as possible. Book presses are typically made from dense hardwoods such as maple, birch, beech, or oak. I found a good local source for hard maple, so that's going to be our material of choice. The finished parts are really chunky, and while I wish I could find solid wood at that thickness, it's just not happening. So all parts will come from 8/4 stock, glued to the thickness that we need. For face glue-ups like this, especially on something that's likely to have to withstand maybe a couple thousands of pounds of force, it's crucial that we get the joint right. The mating faces need to be clean and flat, and when gluing them together, the surfaces need a generous amount of glue. It's also critical that we get nice even clamping pressure. After the glue dries, the blanks are cleaned up at the jointer and planer, and then cut to length. The lower rail is just too big for the miter saw. The table saw doesn't feel like the right move either. So what I'm going to do is scribe around the whole thing so that I've got a nice sharp line to follow, and then I'll make 2 cuts with my track saw. The result isn't perfect, but it's darn close. Any discrepancy can be dealt with by taking a few passes with a block plane and some sanding. The 2 legs, thankfully, can be cut at the miter saw. What's neat about this project is that we have a model right here. We can just copy everything directly off of this project, but if we see an area where we might be able to improve things, not that I know better than the people who made this originally, but if I see something that maybe is easier for me to do, or a way that I could possibly improve it in some way, I'm gonna do that. So, with 3 areas to focus on, our top, our double tenon situation here, and then a connection to the foot, I think I'm going to start with the connection to the foot. It's probably going to be the easiest and simplest, and we'll build up complexity as we go. When we look at the original, we can see that it's a full width tenon, meaning that there's no shoulder on the ends. That can and often does result in a little gap. So we're going to try to do a little better than that. And if you look at the pegs, you can see that they're located pretty close to the outside edges of the joint. We'll likely move those for additional strength. By the way, I did originally try to execute a repair on this leg, which is why it's all glued back together. So I start by laying out the mortises in the feet, as well as the positions for our pegs. I drill the pegs first, because drilling them after the mortises often results in tear out as the bit pushes through the open space. This big of a mortise is a lot to ask of a router, so I'm using a Forstner bit to first hog away the bulk. Then using my router and an edge guide, I can clean up the sides of the mortise. The ends of the mortise then get squared off with a chisel. By the way, this is hard maple, and the process is a lot more time consuming than the video might lead you to believe. But that's a great time to put on your headphones and catch up on the latest Wood Talk, the hit woodworking podcast that's been online longer than you have. Check it out in your favorite podcast app. Now for the tenons. I'm using a cutting gauge for the layout just to improve my accuracy and to ensure a cleaner cut. The weapon of choice for this beefy boy is the table saw with a dado stack and a sled. I don't have a test piece for this, so I'm going to make my test cuts on the very end of the tenon. This way if I cut too deep, I can still correct it for the rest of the tenon. Now my fit ended up a little bit snug, so I'm going to hit the surfaces with my shoulder plane. Alright, that's looking good. Now I'm not ready to do the assembly yet, but I do want to finish prepping for the drawbores. Drawbores are basically just pegged tenons where the hole in a tenon is shifted ever so slightly toward the tenon shoulder. This way when the peg is driven through, it pulls the joint nice and tight. So I'm using the brad point of the bit to show me the current hole location. I could then shift it up and drill the holes. For the feet, I'm going to make myself a little template so that we can transfer the shape to both ends of each foot. This is a little bit different than the original style, but it's pretty standard for things like this. You'll often see workbenches featuring this kind of foot. After the cuts, I can smooth things out with some scraping and sanding. All right, so this next part is going to be a little bit nerve-wracking because we're going to make a change. And when you're changing something that was built in 1905, you really got to think, like, are you smarter than they were? Well, this isn't me making the change. This is Noah requesting a change, and I'm trying to accommodate it in the safest way possible. He has to use a 5-inch block on top of that bottom rail and that bottom platen to take up extra space. The screw just doesn't reach far enough down. And I'm guessing this is because in the past they would just do stacks and stacks and stacks, so they didn't need that thing to come all the way down. For Noah's needs, he has to use this 5-inch block, so we're trying to see if there's a way we could reduce that a little bit. Now, you can bring the bottom up, but you got to be careful because this is a very top-heavy structure. So if we bring the bottom up, we're just adding to that problem. I think we could bring the bottom up about 1.5 inches. You can see the gap between the hardware. The paint is kind of telling us the story here. We can get about 1.5 inches down there safely. And then I think the best solution is to bring the top down. So if we could take this guy down and eat up some of this gap, about 3.5 inches there, I actually think we're going to be in pretty good shape, and we're lowering the center of gravity, making this thing even more stable. And if the top looks a little bit funny, because I cut mine to the same length as the original, we could always just take a little bit of material from the top of these verticals. So I hope it's going to work. That's the plan so far, so let's get into it. Now things are going to get really interesting because we not only need to make another chonky mortise and tenon joint, but it's actually a twin mortise and tenon. And even though there's two, the process is pretty similar to doing just one. It's all about the layout. Now for the tenons, I'm going to use a tall fence on a table saw. I gave this a lot of thought and considered several different alternatives, but this method kept coming back as the most reliable and accurate. I first cut the tenon cheeks. Then I'll nibble away the stock in the middle, which I can clean up later with a chisel. For the outsides, I can make the cuts with the piece on its side. Now because these mortises have rounded corners, I'm rounding the corners of the tenon to match. Even with good layout, the fit is likely going to need some work, but it's nothing we can't handle. The interplay of power tools and hand tools throughout this video is a topic that I discuss at length in my book, Hybrid Woodworking. You can find it on Amazon, or you can get a signed copy directly from me at twwstore.com. People still read books, right? So much of what I'm doing from here on out is incredibly specific to this book press, and I don't think I'm going to dwell on it too long, but I'm really just mimicking what was done on the original. And because the hardware is cast iron, nothing is sharp, flat, or square, so I have to provide relief room in whatever way that I can. For instance, these grooves. I could just cut them a little bit wider, but I'd really prefer the hardware to have a nice, snug fit, so I'm cutting a steep angle using a little guide block. Now with the bottom rail in place, you can see how this is going to come together. For the top cross member, we need to replicate this monstrosity. I think the most important aspect for something like this is the order of operations. If you do the wrong thing first, you can easily remove the material that you might need later as a support or reference. So it's really just a matter of knowing what tools you're going to use and what order you're going to use them in. So all this hardware is held in with bolts, and there's really no measuring here. With these old cast iron pieces, the best thing to do is simply mark the hole locations from the pieces themselves. Now for some finishing touches as we work our way towards assembly. I'll be using some sapelli pegs for the drawbores. It's important to chamfer the end so that the peg can find its way through the offset holes without mangling things on its way through. I'll give the joint a generous coat of epoxy, bring the assemblies together, and then drive the pegs. Epoxy is a pretty good choice here, mostly because it's not water-based and it won't swell the joint, making it pretty hard to put the joint together. The next day, I can trim the pegs flush. Now I told Noah that I'd try to use some JB Weld on the guide rail. Ultimately, these rails don't really take much abuse, they just serve as a guide for that cast iron platen, so maybe we'll get lucky and this fix will hold up. Hey, have you guys heard of bench nuts? They're made by my friends over at Carbon Method, and not only are they great for jokes, they also work well as standoffs for things like sanding and finishing. They provide a nice grippy platform that absorbs vibrations nicely, and it keeps your work from getting dented. So I'm using them to support the bottom platen while I give it a nice sanding. This platen is actually the only wooden part from the original that's making it into the new version. Speaking of Carbon Method, I'm also going to use their rust removal kit to refresh the cast iron platen. We'll do 3 rounds of abrasion using 3 different abrasive pads with Carbon Method's reconditioning oil. This stuff works like a charm. I mean, not doing anything about the pitting, but certainly for the surface, it does a great job. And then once it's clean, I give it 3 coats of carbon coat, and this bad boy's ready for another 100 years of service. By the way, I'm going to include links to both the bench nuts and the carbon coating products in the description. Now for some finishing. I'm testing a couple varieties of natural one coat here, as we're looking for a finish that leaves the maple looking as natural as possible. I tested 2 of them against the regular clear, and it looks like the natural white is the winner. As you can see, this stuff has a decent amount of white pigment in it, and that's where the magic happens. It's the white pigment that pulls back the natural warmth of the oil. I'll apply 2 coats of the finish over the course of 2 days. Now the bench nuts can go back in their nutsack, and as much as I'd love to take credit for that pure old joke, that's actually what they call it. Don't shoot the messenger. So now the only thing left to do is to load up all the new and old parts and head over to St. Louis to see Noah. After loading everything in, I took a few minutes wandering around Noah's shop. It's always neat to see the working space of a craftsperson that exists deep within a niche. So this is actually the first time I'm seeing this thing go together. I'm pretty sure it's going to fit, but I guess we're about to find out. It's at this point that you can really start to understand the role of the additional cast iron supports. We've got a set under the lower rail that helps support all of that downward force. And then there's another set above the cross member that helps resist the upward force. It's pretty cool. Alright, so let's watch the rest of this thing go together. Now I let Noah do the honors of taking the old Hickok badge off and attaching it to the new press. Now you might be curious about what Noah actually does with a press like this. Let's see an example.
So this is the final part of putting a book together, so gluing the text block into the case. Then we'll use the press to set this, because obviously gluing out paper, it wants to move a lot. And so the press provides enough pressure to keep it from wrinkling and moving in ways we don't want it to. And the glue I'm using here is PVA, and so very similar to wood glue, it's just PVA without any of the additives you would find in wood glue. And so I'm going to be putting 1 book into this press. Historically, these presses are so wide open because in production you would be loading in as many books as you could fit. So that might be coming out the front, the back, the sides, anywhere from 10 books at a time to some of the larger presses. I mean, you're getting upwards of 50 or 60 books at a time into them, depending on the size of the book. So these are pressing boards. These have a metal edge. Historically, they would have been brass. These have an aluminum edge, and that is to help set the joint between the spine and the cover. And so get this down here close. And really crank it down to help keep the paper from buckling, as well as to set those joints. So this would stay in the press anywhere from 2 hours to overnight. And it's kind of, if I didn't need the press before then, I would probably leave it overnight. It doesn't hurt anything to have it in there longer. I get everything. I deal with private individuals all the way through institutions like museums and libraries. So that can be everything from family Bibles, family heirlooms, all the way to
early printed books from the late 1400s or manuscripts that are even older than that. I would say the bulk of things I work on are 19th century, so 1800s, and a lot of that is with private individuals, especially late 1800s. The big family Bibles that people have seen, those were mostly made in Philadelphia and New York. They were sold door to door, made out of the cheapest materials available. I see a lot of them that people want repaired. And sometimes it's a conversation about, is it worth it to repair the entire thing because they can be pretty damaged? Or is it worth just repairing the family pages that have births, deaths, and marriages on them? That's really what's important to people in those Bibles.
Interesting stuff.
So there it is. Something a little bit different for you guys, and I really hope you enjoyed it. And thanks again to our sponsor Woodcraft for helping to support the show. Check them out at woodcraft.com.